Alright guys, so in this lecture we are going to practice more questions for the medicinal chemistry. So we are going to practice from number 11 to 19 remaining ones for this lecturer's part. Now we have the first question under this section, which states draw the structure of cocaine and label the heterocyclic nucleus. Comment on the biological activity of cocaine and its SAR. By the way, SAR means structural activity relationship. How does the modification of the structure of cocaine affect its biological activity? So the first thing we need to do is to draw the structure of cocaine. Now, in order for us to draw the structure of cocaine, the first thing we need to understand is we have to draw benzene structure first. Something like benzene, but here one of the carbon of benzene have been replaced by nitrogen. So we have this nitrogen, a CH3 attached to it, and then inside this ring you have a bicyclic compound, all right, which is more like something like this. Is bicyclic. Bicyclic is when you have two circles in one, all right. So this is a bicyclic compound, and then after this, the next thing you are going to write is a hydrogen that is going out of plane, so indicate it. Now you have an ester group here connected to benzene ring, all right. Now here you also have another hydrogen going out of plane and another ester group, but this one is connected to CH3. Is that okay? It's connected to CH3. So what are the structural features in cocaine structure? You can actually see here. This is the structure of cocaine. All right. What are the structural features? You discover that you have a benzene ring. All right. You have the benzene ring. Then inside of the benzene ring, you have not necessarily benzene ring. This ring is called a piperidine ring. And another thing is, they say we should label the heterocyclic nucleus of cocaine. So if you want to label the heterocyclic nucleus of cocaine, the heterocyclic nucleus, now you have this bigger ring here which contain this nitrogen here. This bigger ring, 6-member ring. If I want to count, let me say this ring 1 2 3 4 5 6. This ring I just labeled now, all right, is a more like a benzene ring, but it's called a piperidine ring. Piperidine. So that is a heterocyclic ring. Now what do we mean when we talk about heterocyclic ring? We talk about a ring that contain a hetero atom. The hetero atom is nitrogen, oxygen, and sulfur, etc. So it's that this ring actually contains nitrogen. Now we have another smaller ring that also contains nitrogen. If you look at it, this ring here, 1 2 3 4 5. This smaller ring here also contains nitrogen. All right. Now what is the name of this ring? This ring is called pyrrolidine. It's actually a pyro ring, so you call it a pyrrolidine ring. Pyro ring, but it does not have the two double bonds that are present in pyro. So hence you call this a pyrrolidine ring. Is that okay? So these are the heterocyclic nucleus that are present in cocaine. Now when we talk about the structural activity relationship of cocaine, there are some important things you need to look at. They say discuss, comment on the SAR. Now on the SAR, when cocaine breaks down, what do you think is going to form? When cocaine breaks down, what do you think is going to form? When cocaine breaks down, this is the structure of cocaine. When this cocaine breaks down, so we can have cocaine. The breakdown of cocaine, the breakdown of the structure of cocaine is called hydrolysis. It's called what? hydrolysis. So when this breaks down, what are you going to form, my dear student? You are going to form 3 different structures. Now, you are going to form this ring here. This ring is called agonine ring, but it's going to be hydrolyzed. Now, when it hydrolyzes, this group here will be hydrolyzed to give us OH. Why this group here will be hydrolyzed to give us a carboxylic acid. This group here will be hydrolyzed to give us carboxylic acid. This group here will be hydrolyzed to give us OH. So what are the structures that we are expected to form from the hydrolysis of cocaine? We are going to form something like this, then something like this, then CH3. All right, then you are going to have this one going out of plane, hydrogen. Told you that when this group hydrolyzes, it's going to give us OH. Then when this one will still have this hydrogen going out of plane. Then when this one here hydrolyzes, it's going to give us COOH. Now, what structure is this? This is structure of what we call egg guanine. All right, this we plus. Now, although you know this thing hydrolyzed, this is an ester. So when an ester hydrolyzes, it's going to give us alcohol and what? Carboxylic acid. When an ester is hydrolyzed, it's going to give us alcohol and carboxylic acid. So the alcohol group is already found here. So it means that this other group here, which is the benzene group, will be a carboxylic functional group that will be present there. So this is going to give us OOC, which is also known as benzoic acid. So this is going to give us a benzoic acid, plus this group here we also hydrolyze. This is also an ester. So when the ester also hydrolyze, the ester is going to hydrolyze, and when I mean the ester, I mean this particular one here. All right, when this hydrolyzed, it's going to give us carboxylic acid and alcohol. The carboxylic acid is already formed, so we are left with what? The alcoholic group. Is that okay? So this is going to form an alcoholic group, which will be CH3OH, which is methanol. All right, so these are the products that will be formed from the hydrolysis of cocaine. So you are going to form benzoic acid, you are going to form methanol, and you are going to form agonine. It's a very important objective question. The hydrolysis of cocaine can give the following product, except you may see agonine, you may see benzoic acid, you may see something like hyoscyamine, you may see methanol. Correct answer is what? Hyoscyamine. Hyoscyamine is not a hydrolyzed product of benzene, of cocaine rather. So this is the structure of cocaine. So for those that smoke cocaine or for those that sniff cocaine, this is how the structure actually looks like. This is what you are sniffing. All right, you're going on 9. You're lying in the hard hole. All right, so that is that. So that's the structure of cocaine. Now, the removal of the benzoic group leads to loss of activity. Structural activity relationship. Now, let us look at the structural activity relationship of cocaine. If you remove this benzoyl group from here, it actually leads to loss of activity. Hence, the benzoyl group is important for its activity. Now, there are 3 groups that you can actually remove. You can remove the benzoyl group from the main structure of the agonine. You can also remove the carboxymethyl group. All right, carboxymethyl group, like this one is carboxymethyl. All right, this is carboxymethyl. Now, if you remove this carboxymethyl group, it does not necessarily affect the biological activity of cocaine. All right, now at low dose, cocaine produces feeling of well-being, reduced fatigue, that is tiredness, and increases alertness. Now, it tends to produce compulsive drug seeking habits, right? When you talk about compulsive drug seeking habit, means it has an addiction liability, and a full-blown psychosis may even emerge. We'll talk about full-blown psychosis, schizophrenia, like the person does the scoy. Are you getting it now? So that is the structural activity of what is it called, of cocaine. First, cocaine can break down into ergonin, benzoic acid, and methanol. I know this breakdown here is not structural activity relationship anyway, but it's part of the material, so you are going to write it that way. That when cocaine breaks down, it breaks down into ergonin, benzoic, and methanol. Now, the removal of the benzoic group has significant impact on the activity of cocaine. So the benzoic group is important for its activity. However, the carboxymethyl group, the benzoic group is the one that represented with A. Carboxymethyl group is the one that represents with B. The carboxymethyl group does not necessarily have any effect on the activity of cocaine. All right. Now, that is what I wrote here. Removal of the benzoic group leads to loss of activity. Hence, the benzoic group is important for activity. Removal of the carboxymethyl group does not have adverse effects on activity. At low dose, it produces feelings of well-being, decreased fatigue, and increased alertness. It produces compulsive drug-seeking habits, and a full-blown psychosis may emerge. Is that okay? So that is that for cocaine. For that question, outline the clinical uses of local anesthetics. What are local anesthetics used for? What are some of the usefulness, the clinical applications of these local anesthetics we are talking about? Now, the first one we have here is surgical anesthesia. Local anesthetics are given in surgical anesthesia, especially in minor surgeries, dental procedures, and for dermatological procedures. All right, you can use local anesthetic. Then in pain management also. Then regional anesthesia. Local anesthesia may act as regional anesthesia in particular region of the body. They can act as peripheral nerve block, epidural anesthesia, spinal anesthesia, and then in diagnostic procedure like biopsy and endoscopy. Biopsy, we talked about removal of tissue from the body for laboratory examination. Then endoscopy is actually taking something into the body to visualize organs and various tissues. Then pain in labor, this one is for epidural anesthesia into the dura mater. All right, so these are some of the clinical uses of local anesthetic for surgical anesthesia, minor surgery, dermatological procedures, and dental procedure. The regional anesthesia into region like the peripheral nerve block, epidural anesthesia, and spinal anesthesia. Diagnostic procedure like biopsy and endoscopy, pain relief in labor. All right, so that is that. Another name for lidocaine is lignocaine. Lignocaine. Now, the brand name for lidocaine is xylocaine. That's the brand name for lidocaine. So this one here is a brand name. So, and this one is the other name for lidocaine, lignocaine, or that. Draw the structure of lidocaine, procaine, and benzocaine. Now you have these three structures. Let us start with the third one, which is benzocaine. What is the structure of benzocaine? Benzocaine is the easiest, something like this: CO, all right, and then you have C2H5, and then here you have NH2. That is structure of benzocaine. All right, exactly. That is structure of benzocaine, which is also called ethyl 4-aminobenzoate. So you can also come here and say the name for lignocaine. Okay, not that is benzocaine, they are not lignocaine. All right, so you call it ethyl what? 4 amino benzoate. If you calculate, if you number rather, here will be number 1, here will be number 2, here will be number 3, here will be number 4. Position number 4, you have amino group. This one is ethyl as a substituent on the benzoate group, then 4 amino. Then where is the ethyl coming from? Now this one here, are you getting it? So ethyl 4 amino benzoate, because it's an ester of benzoic acid. So that is that for lidocaine. Now the next structure we are going to draw is the structure, benzocaine rather, the structure of procaine. Now from this structure we are able to get procaine. How? It's still very easy. All of them have this NH2. They have the NH2, and this is not CO only, COO. All right, so here you are having another O here, and they also have this COO group. Now, but the distinguishing feature between benzocaine, procaine, and the rest one is this. Now let's draw procaine. Procaine still have the NH2, which I will represent with H2N. Then the benzene ring. Please take note of how to draw these things now. COO. Then after the COO, what you now have is CH2, CH2. You know this one just ends as C2H5, which is CH2, CH3. But after the C last CH2 here, they now have N before you have C2H5, C2H5. So this one here is the structure of procaine. This is the structure of procaine. Now let me try procaine. Alright, let me try and draw lidocaine. So you see these two here, they are ester derivative. However, lidocaine is an amine derivative. Is that okay? So lidocaine has a different this thing entirely. It's still the same thing. You still have the you don't have NH2 here for lidocaine. All you have is just something like this, the benzene ring, and then you have NHCO. All right, then after this, so you now have CH2 and C2H5 here, C2H5. So you must practice these structures every morning from now till the day of the exam. When you wake up in the morning, what are you going to do? You come to this material, draw the structure. This is the structure of benzocaine. Is the easiest one you can actually see here. Then when you worked on benzocaine, remove this, write the CH2 out, then put N, then C2H5. You get what? Procaine. And then this one is the amine derivative. Is the amine. You can actually see it here. This is the amine functional group. It's quite different from this one here. These ones, they are esters. All right, so you should be able to distinguish. Lidocaine is an amine, while benzocaine and procaine are all what? Esters. Is that okay? Now that is that for the structures. In what conditions are they meant to be stored? According to what I said here, they are to be stored in airtight, supposed to be airtight container, or airtight light resistant container. That is the method of storage.